Okay, in this section, I thought we would go over a couple of questions and some definitions in order to better understand the information that has been given so far. Now, the first question is going to ask how many possible values for a particle with 10 pressure cells and a max compression of 8. What that means is that there are 10 pressure cells, each with a value, which is the value is the rate, right? And the max rate is 8, and this is repeatable. All right, so then all we do is take the max rate and we set it to the power of 10, right? That's all we do for this question, and that value is 1,073,741,824. Now, how do we know what this value is? Well, if we take a much more simple example, we can see that there are 2 cells, right? And let's say that each cell is a max rate of 8. So we can set this 1 through 8, and we can simply add 8 for every value, right? So we just do, for the value 1 in cell 1, we can just simply say 8 for the value 2 plus 8 for the value 3 plus 8, and so on and so forth until we get the answer. But that's very long, so we just use this nice little shortcut in order to determine exactly what the value is. Now, the second question asks, given these numbers, draw a percentage diagram next to them indicating 18's required expansion for interaction. What that means is that 18 is a pressure value and these are other pressure values, right? And what it's asking is how far does 18 have to travel in order to interact with all of these pressure values. Now, the first thing is to convert these to all to pressure percentages. They are 600, 600, 900, 600, 600, 900, 225, 600, 100, 100, 900, and 600, right? So since there's not enough room, I'll go ahead and erase a little bit. So if you want to write down this, go ahead. In any case, I'll erase a little bit. Now, for the next step, we simply multiply these percentages by that value. Remember, these are percentages. This is not 600 times. This is 600% or 6, right? This is not 225. This is 2.25, okay? Now, in order to get those values, we simply multiply the percentages, and that would be 108, 108, 162, 108, 108, 162, 40.5, 108, 18, 18, and 162, and 108. So these are distances. As you notice, this value is a decimal. And so as we know, rates cannot be decimals or fractions for that matter, we know that these are distances and not actual rates. Okay, so this has 18 has to travel 108 units in order to interact with 3. 18 has to travel 40.5 units to interact with 8. Okay, that's the way it works. Now on to the definitions. I'll go ahead and put all of the definitions up on the top of the whiteboard, and you can go ahead and look at this board and try to answer all of these before I put down the definitions that I have on my board. Okay? Now, the words that we're defining are expansion, kinetic, potential, law of minimums, void, active system, and state-based system. Now for expansion is the activity that makes every day. You know what? I'll go ahead and show the other board. Okay, so now you have all of these definitions. I'll go ahead and show the other board in order to give you the information. Now, let's try and get rid of that glare. Expansion is the activity that makes everyday life possible. and it is also the two voids trying to escape each other in the best way possible. Okay, so it's two void values trying to push away from each other. And kinetic is expansion, right? So expansion is the activity of the universe because kinetic is active energy. Potential energy, however, is the pressure under a special rule. This is what this F means, right? So this is a special unit that we'll go ahead and define in a little bit. The law of minimums is the universe will always step down the rate if possible. It will always try to find every possible way to step down the rate. If it can't, it will go up. Okay, so that's the law of minimums. It will always step down. Void is empty space. Since infinity divided by infinity is equal to 1, its value is always 1. Keep that in mind. What that means is that a big piece of void and a small piece of void are equal to the same value because void is void. Okay? These are both void and they're both equal to the same thing. So thus, void is equal to 1. An active system is a system where change determines the action. So that means that every contribution is made. Let me go ahead and adjust that a bit. An active system is a system where change determines the action. What that means is this is a system where you have X increasing, right? And as X increases, then we get the perceived universe. Perceived okay, so all of the objects that we see, all of the things that we experience, all the sensations and all of that, if it were an active system, everything would be a consequence of change. Once change happens, then a consequence happens. A state-based system is a system where the instructor determines the action. That means that an instructor has to be there to tell the universe exactly what to do. We already explained why this is impossible. In any case, this is going to be an overview. If you still have questions, well, I'm going to try to be online occasionally because I'm not very good at speaking, as you might have noticed. That doesn't matter though. I'll go ahead and try to answer questions as simply as possible. In any case, this is going to be the question section, and the next section is going to explain exactly how to determine what value void is when two void is pushed together.